Question 6.6, we're going to explore inverse trig functions. Now, some things about inverse trig functions and other functions are exactly the same. For example, if we were to graph y equals sine of x, I think sine starts at 0 and becomes positive. It's 0 becomes negative, comes back to here. And I'll just draw this over on the positive side. What about the inverse? Well, remember that this starts out at 0, 0. And so if I reverse those x and y values, I'm going to start at 0, 0 here. I become positive for a while, and then I become 0 again. And this happens, the sign is 0 when, when the x value is pi, the y value is 0 again. It happens again out here when the x value is 2 pi, the y value is 0. And right here, like we said, 0, 0. So if I want to, in blue, graph the inverse, I've got to flip-flop these x and y values. Well, you flip-flop 0, 0, you're still at 0, 0. You flip-flop these guys, and you have 0 pi. You flip-flop these guys, and you have 0, 2 pi. And so what this would look like, something that looks like that. Now, does that look like those are reflections over the line y equals x? And you'd look at it and say, yeah, that looks pretty good. Okay, so the same thing holds true for inverse trig functions as it does for inverse any other kind of functions. They are reflections over the line y equals x. Now some terminology. When we're talking about the inverse sign, sometimes James and sometimes AP refers to that as the arc sign. So just be aware of that vocabulary. Written in symbolic language, inverse sign, arc sign, those mean the exact same thing. Now, if I'm given this statement right here, that y is equal to the sine of x, we know that x is some kind of an angle measure. The sine of pi over 4. And what's the sine of pi over 4? And of course, you guys know the unit circle, and so you'd say, oh, that's square root of 2 over 2. So what that's equal to, what y is a number. It's not an angle measure, it is a number. Now, what if I'm given something like this? And you know what? I'm just going to cross this out, and I'm going to rewrite it a little differently. I'm going to write it like this, because you guys are accustomed to switching the roles of x and y. So if we flip-flop the roles of the x and the y, what is the y number? Well, the y number is still the sine inverse of a number is equal to an angle measure. So let's take a look at this. Remember, this is a number right here. And if this is a number, the sine inverse of a number is equal to an angle measure. Our job is to find the angle measure. And I'm going to ask you to write something down. I'm going to ask you to write down that the answer to sine inverse and tan inverse, which we're going to run into right now. The answers to these kinds of questions, whenever you're asked to find the sine inverse or the tan inverse of a number, the answer is in the first or fourth quadrant. The angle measures you're looking for are in the first or the fourth quadrant. And they go from negative pi over 2 to pi over 2. We'll be drawing some unit circles to solve these. Now, cosine inverse. Those are always found between 0 and pi. We'll see if we run into a cosine inverse today. So let's take a look at y equals sine inverse of 1/2. Now, if I ask you, what's the sine inverse of 1/2, you'd say, I don't know. Understandable. So I'm going to say, okay, what's the inverse of this? Well, couldn't I write this as 1/2 equals the sine of y? Just flip-flop the x and y. Okay. Now, the sine of what angle is 1/2? I think of my unit circle. And as I think of my unit circle, I realize that sine is the y value. That occurs right here. That's where the sine is 1/2. You know, it also occurs over here. But remember, and this is pi over 6. That's where the sine is 1/2. If we know our unit circle, we know that. If we don't know the unit circle, well, we got some work to do. That's 5 pi over 6. So the question is, find y. How big is y? The sine of what angle is 1/2? And I would say pi over 6. And I'm tempted to also say 5 pi over 6. But from what we wrote down up here, sine inverse and tan inverse are always in one of these two quadrants. So I'm not going to write 5 pi over 6. I'm going to say that the angle that causes the sine to be 1/2, that angle is pi over 6. All right, well, that's going to take a little getting used to. This next one, y equals tan inverse of 1, we rewrite this as 1 is equal to the tan of y. So what's the angle measure? At what angle measure is the tangent 1? So I again think of my unit circle. Where is the tangent 1? Where is sine divided by cosine 1? Well, sine and cosine are the same right here, pi over 4. And also down here at 5 pi over 4. And if sine and cosine are the same, then when you take sine divided by cosine, you're going to get 1. So I think the angle measure that causes the tangent to be 1 is pi over 4 and 5 pi over 4. But again, keep in mind that the answers to tan inverse problems are limited to the first or fourth quadrants. Your answer is only valid if it goes from negative pi over 2 to pi over 2, somewhere in here. And so the 5 pi over 4 doesn't fall into there. My answer is y is equal to pi over 4. All right, we move on. That's a busy first slide. Cancellation property. If you take the sine inverse of the sine of x, you're going to end up with x. The sine and sine inverse cancel each other out, leaving you with the x. Same thing is going to happen here. If you take the sine of the sine inverse of x, these guys cancel each other out and you're left with x. All right. Now, find y if y is equal to cosine of the sine inverse of a half. You have already found this. On the previous slide, you have already found this angle measure. So what you're asked for here is y is equal to the cosine. If you look back on slide 1, sine inverse of pi over 2, I'm sorry, of 1/2 was pi over 6. Now what's the cosine of pi over 6? And you think of your unit circle, and I think you're coming up with that. Next one, y is equal to the sine of the tan inverse of 1. You have already found tan inverse of 1 on the previous slide. Y is equal to the sine tan inverse of 1. It was pi over 4. And so that is going to be, now again, I got to know my unit circle. I believe the sine of pi over 4 is square root of 2 over 2. Now, I don't know what the cosine inverse of 3/5 is. I can't say that's pi over 6 or pi over 4. That's not on the unit circle. When I'm faced with something that isn't on the unit circle, and you can expect to see this on maybe a test or a quiz, we're going to really emphasize today drawing a triangle. Now, here's how we're going to do that. We're going to get some more practice with this. Cosine inverse of 3/5 is equal to, I don't know what it's equal to, which would lead me to say that 3/5 is equal to the cosine of some angle. And that's the angle I'm looking for. So what I'm going to do is I'm going to draw a triangle that represents this situation. I'm going to have a nice right triangle here. And I am going to make this angle right down here a question mark. Now the cosine of that angle is 3/5. I think, what is cosine? Cosine is adjacent over hypotenuse. So the cosine of this angle, adjacent over hypotenuse, is 3/5. So I'm going to make the adjacent side 3 and the hypotenuse 5. Now, if that's the case, can you tell me, from back in geometry, how big is that side? And hopefully you would recognize this is a 3, 4, 5 right triangle. So when the question says y equals sine of cosine inverse 3/5, and we have said that cosine inverse of 3/5 is some unknown angle. We want the sine of that unknown angle. Can you look at this drawing right here? Can you look at that drawing and tell me what the sine of that angle is? Well, since sine is opposite over hypotenuse, y is equal to the sine of that angle, 4. Oh, we're going to get some more practice drawing triangles. The triangle method for the derivative of an inverse trig function. Now, I'm going to tell you something. There are only 2 inverse trig functions you need to know the derivative of. You need to know the derivative of the sine inverse of x, and you need to know the derivative of the tan inverse of x. Those are the only ones I have ever seen come up on the AP exam. Triangle method for the derivative of an inverse trig function. Okay. Find y primed if y is equal to sine inverse of x. Good. We are going to find, and you will need to know, the derivative of sine inverse. So the first thing I'm going to do is rewrite this. I'm going to write this as x is equal to the sine of y. Piece of cake. We've been doing that with inverses in this chapter. Second thing we're going to do is we are going to draw a triangle. We're going to draw a triangle where x is equal to the sine of y. Same thing we just did. We're going to draw ourselves a right-hand triangle. So a right-angle triangle. Where now the angle measure is y. And the sine of this angle, the opposite divided by the hypotenuse, is x. So I'm going to make opposite hypotenuse. And if I take opposite over hypotenuse, do I indeed get x? Have I drawn a triangle where the sine of angle y is equal to x? Okay. Now, when I draw this triangle, do you think it's going to be important to know the length of this side over here? And I think you're going to say, yeah, that's going to be important. Well, you know that a squared plus b squared in any right triangle is equal to c squared. Or that c squared, that c squared minus b squared would be equal to a squared, right? Just subtract b squared from each side. I'm looking for this side right down here. To find this side, could I take hypotenuse squared minus one side I do know, and that's equal to that unknown side down there squared. Now, if I took the square root of each side, that unknown side would be equal to the square root of 1, because that's what 1 squared is, minus x squared, and I don't know what that is. So this side down here is the square root of 1 minus x squared. So I have drawn a triangle that represents the situation in step 1. And the third and final thing I'm going to do is take the derivative. Of step 1. Okay. If I have x is equal to the sine of y, what's the derivative? What's the derivative of x? Equals, what's the derivative of the sine of y? Well, that kind of looks like a chain rule to me, because I've got parentheses. Derivative of the outer, don't mess with the inner, times the derivative of the inner. And the derivative of y is y primed, and that's what we're looking for. So if I divide each side by the cosine of y, if I take 1 divided by the cosine of y, that will give me y primed 1. So what's y primed equal to? 1 divided by, take a look at this triangle. What is the cosine of y? What is the adjacent divided by the hypotenuse? Well, adjacent divided by the hypotenuse, and the hypotenuse is 1. So I think that 1 over the square root of 1 minus x squared, that's y primed. That is the derivative of the sine inverse of x. 1 divided by 1 minus x squared, take the square root of that. That's the derivative of sine inverse. Now that is something we'll see in a table a little bit later on page 457 in the book. But that is a piece of information we're going to hold on to. Find y primed if y is equal to the tan inverse of x. All right, well, we're going to follow those same directions. First thing we're going to do, flip up the roles. X is equal to the tan of y. We're going to draw a triangle of that situation. Remember that the angle measure is y, and the tangent of that angle is equal to x. Now, tangent is sine over cosine. Tangent is opposite over adjacent, and opposite over adjacent better be equal to x. So if I say opposite adjacent, my tangent is indeed going to be x. And it's going to be a good idea when I draw the triangle to find all 3 sides. I got 2 of them. I need that third one. And again, keeping in mind that a squared plus b squared equals c squared. 1 squared plus x squared is equal to that hypotenuse squared. So if I just want the hypotenuse, not hypotenuse squared, I'd have to take the square root of each side. And so this hypotenuse right here is the square root of 1 plus x squared. So I've rewritten the problem. I've drawn a triangle of that situation. And now I have to take the derivative of what I wrote here in step 1. And the derivative of x is again 1. The derivative of tan of y, now again, looks like a chain rule. Derivative of the outer, secant squared. Don't mess with the inner. Times the derivative of the inner. And we're looking for y prime. So y primed will be equal to 1 divided by secant squared of y. Okay, so now I just got to find out what secant squared is. Okay. Now, oh, what do I know? I know secant is the reciprocal of cosine. Secant y is the reciprocal, or 1 over cosine of y. So I'm going to start to be thinking about secant here. Y primed is equal to 1 over. Now I got to find secant. Secant is the reciprocal of cosine. Cosine is adjacent divided by hypotenuse. So secant is going to be hypotenuse divided by adjacent. The secant is the square root of 1 plus x squared divided by 1. But I'm supposed to have secant squared, so I better square that. And when I do, I get y primed is equal to 1 over 1 plus x squared. And that is the derivative of tan inverse. Tan inverse of x. That will be a huge piece of information. We've just proven it. We never have to prove it again. If I can memorize that, I never have to prove it again. If I can memorize the derivative of sine inverse and the derivative of tan inverse, I never have to prove it using this triangle method again. All right, final slide. Use the previous examples in the chain rule to find y primed if y is equal to the sine inverse of 2x. Okay. Now, I know that if y equals sine inverse of x, then y prime was equal to 1 over the square root of 1 minus x squared. I know that. But now in the parentheses, instead of a plain old x, we've got a 2x. So if y equals the sine of 2x, then y primed equals 1 over the square root of 1 minus, well, it's going to have to be this thing right here squared. It's going to be that thing in parentheses. It's going to be that 2x that has to be squared. And it says to use the chain rule. And the chain rule says, hey, if you see parentheses like we did right here, don't forget at the end to multiply by the derivative of what's inside. And what's the derivative of what's inside? So, the derivative of sine inverse of 2x, the derivative of that y primed is equal to 2 over the square root of 1 minus, and if you want to write it as 2x, that quantity being squared, if you wanted to write it as 4x squared, either way, that's fine. But by knowing what the derivative of sine inverse is, I can now apply that, finding the derivative of the sine inverse of anything. You might say, okay, why didn't you worry about multiplying by the derivative of what's inside? Well, the derivative of what's inside is just 1. So know what the derivative of sine inverse is. Here's advice to take a look at that table on page 457 possibly for any problems on your homework assignment. Now, when I ask you questions on a test or a quiz, when AP asks you questions, they're only going to require that you know derivative of sine inverse and tan inverse. There might be something on your assignment that has cosine inverse in it, something like that. If so, use that table on page 457. Okay, here's what I know. That if y equals tan inverse of x, then y prime equals 1 over 1 plus x squared. Proved that on the previous slide, memorized it. So, what am I going to do here? If y is equal to the tan inverse of this thing, then y primed is equal to 1 over 1 plus, looks like that thing is supposed to be squared, doesn't it? And then I got to remember to multiply by the derivative of what's inside. And the derivative of what's inside, I think, is so if I clean that up a little bit, I say y primed is equal to, I think there would be a negative 2x on top. On the bottom, I'm going to have a 1 plus, and you know what? I don't want to make a mistake squaring that thing. I'm just going to write it like this. If I make a simplification error, it's an error. I don't want to make one. I'm just writing it like that. Now, this is going to take a little bit of practice and a little bit of doing some of the problems and then checking the solutions, seeing how you did, going back and fixing whatever it is you may have done wrong. And you'll have an opportunity to practice this on your homework tonight.